Hi everyone, so today we are going to practice graphing rational functions using algebra. Yes, you can graph rational functions in your graphing calculator, but let's go ahead behind the scenes and see how we do all of the graphing using algebra. So we're going to look through several examples together and we're going to pick apart how we find certain characteristics. Now with this first function, what we're going to do is we're going to find our x-intercepts. So with our x-intercepts, we are going to be able to find the real zeros of your numerator. So we're going to take our expression that's in the numerator, set it equal to 0, and solve for x. So now we get x is equal to -4, then my x-intercept is at -4, 0. Whenever you want to find a y-intercept, what we're going to do is we're going to see where my graph crosses the y-axis. So my y-intercept is where x is going to equal 0. So what I'm going to do is I'm going to take 0 and I'm going to plug it in for x in my function. So I'm going to take my function and now I'm going to simplify. So I've got 8 over 8, which simplifies to 1, which means my y-intercept is going to be at 0, 1. So I have my two dots. Now what I'm going to do is I'm going to go ahead and figure out where I have asymptotes. So the first thing I want to do is find out where do we have our vertical asymptote. Now, my vertical asymptote, I'm going to be able to find that out, finding the real zeros of my denominator. So I'm going to take that 8x plus 8, set it equal to 0, and solve. So I get x is equal to -1. So that's going to be my vertical asymptote. So remember, with any asymptote that you draw, they are lines and they are going to be dotted lines. So my graph is going to get kind of close to these asymptotes. They may or may not cross, but for sure vertical asymptotes, our graph cannot cross them at all. So I've got a dotted vertical line right where x is equal to a -1. Now with my horizontal asymptotes, what you have to do is you have to look at the degrees of your function. So looking at the exponents. So in the numerator, I have an exponent of 1, as well as in the denominator. So that's what we kind of call even Stevens. My degrees are even. So in this situation, when my degrees are the same, I'm going to divide the lead coefficients. So 2 over 8 is simplified to 1 over 4. So my horizontal asymptote is right at y is equal to 1/4. Again, dotted line going horizontally. So now what I can do is I can go ahead and make curves. And again, notice how my black graph is getting really close to those asymptotes, but they don't ever touch them or cross them. So I've got two little branches of my graph. Now we're going to take the same graph that we had, and now we're going to figure out what to do about domain and range. So with my domain, remember I've got all possibilities of x's. Now in this case, accept values that make your denominator equal 0. Note that that's where we technically had a vertical asymptote. So I'm going to take that expression and I'm going to see, okay, well, the only x value that my domain cannot include would be at that -1 where I had my vertical asymptote. So my domain is going to be all real numbers, and x cannot equal -1. With my range, I'm looking at my y's. So when I look at my graph, I want to see, are there any y values where my graph cannot be included in my range? So I actually do have a horizontal asymptote right at 1/4, but notice that my graph doesn't cross or touch the horizontal. In this particular function, my range is going to be all real numbers, and then y just cannot equal 1/4. Okay, so let's tackle another example. Here's another function. And again, let's look at these specific characteristics and let's put our appropriate information on our graph. So x-intercepts, remember, zeros of your numerator. So I'm going to set my expression in my numerator equal to 0. And I'm going to get x is equal to 3. So my x-intercept is going to be at 3, 0. For my y-intercept, I'm going to take my 0 and I'm going to plug it in wherever I see an x. I'm going to simplify. I get 3 over 12, which simplifies to 1/4. So my y-intercept is at 0, 1/4. All right, now let's take The same information that we did in our previous example when we're talking about asymptotes. So my vertical asymptote, again, finding the zeros of my denominator. In this case, you can notice that you do have a quadratic expression in your denominator. So you can factor that. You can do the box method. You could do guess and check. We could split the middle. So as whatever method you need to do in order to factor, I'm going to get x minus 2 and x minus 6. So when they're set equal to 0, I actually have two vertical asymptotes. One at 2 and one at 6. So again, dotted lines going up and down. With my horizontal asymptote, again, looking at the degrees. So the degree of the numerator is a 1, right where that x is. The degree in the denominator is a 2, so my function is actually bottom heavy. So my degree in the denominator is bigger. So when we're bottom heavy, we're going to always have an asymptote at y is equal to 0. Now we're going to draw the branches appropriately. So now you have 3 different branches. So let's use this graph, help us define domain and range. So with my domain, again, all possibilities of x's. So we already had those vertical asymptotes. We already factored that denominator. So my domain is going to be all possibilities of x's, all real numbers, except 2 and 6, because I have those vertical asymptotes there. For the range, again, remember you have to look at your graph. So in this case, this was an exception where my graph is actually going to cross my horizontal asymptote. So I do have an x-intercept there. So in this particular example, my range is going to be all real numbers. Okay, last example together. Finding x-intercepts, taking that expression in the numerator, setting it equal to 0. So I have an x-intercept at 0, 0. Y-intercept, taking 0, plugging them in for x, and simplifying, get 0 over 9, which simplifies to 0. So my y-intercept actually happens to also be the same as my x-intercept, and that's okay. That could happen. Now my vertical asymptote, setting my denominator equal to 0. So what you're going to notice is that when I set my denominator equal to 0, I'm going to get x squared is equal to -9. Yes, you can solve that algebraically, but then you're going into imaginary numbers. I can't graph imaginary numbers. I can't graph anything that's not real. So in this case, my vertical asymptote, I don't have any, so I'm going to write none. For my horizontal asymptote, here we go. Look at the degrees. So I have a 4 in the numerator, 2 in the denominator. So I'm top heavy. So numerator being larger. So whenever I'm top heavy, I don't have a horizontal asymptote. So no horizontal and no vertical asymptotes. For my graph, we're going to have something similar, kind of like a shape like a parabola. And that's going to help us when we find out our domain and our range. So with my domain, I'm looking at all possibilities of x's. Again, remember that we didn't have any vertical asymptotes, so my domain is going to be all real numbers. For my range, what is the possibility of my y's? I have the smallest possible y as 0 with a bracket there because it is included, going all the way towards infinity with a parenthesis. Okay, here are some things to remember. Always remember your asymptotes must be written as an equation. It is technically an equation. So x equals or y equals. And make sure to look at the degrees or the exponents, right? Degrees are exponents of the rational function in order to help you find your horizontal asymptotes. So I hope this video was helpful and you'll learn how to graph rational functions using algebra. So thanks for watching and we'll see you next time.